Hi, this is Ajit. Welcome to Step by Step Data Science tutorial. This is part 2, multivariate linear regression. So in this video, we will be covering the exploration of our data. Then we will write machine learning equations for feature normalization. Then we will write hypothesis equation, cost function, gradient descent, R2 score, and finally we will verify our result with linear regression model of scikit-learn. So let's start. In the last video, we discussed about univariate linear regression. So in a univariate linear regression, we know that okay, in a univariate linear regression, our h theta of x was theta naught plus theta 1 x. We only had one feature. So this was called univariate because we only had one feature. Okay, so right now uh, we are working on multivariate linear regression. So our hypothesis will be h theta of x equals theta naught plus theta 1 x1 plus theta 2 x2 plus so on up to theta n xn. Okay, so let's start. So this is my library machine learning course. I'm using that data set. So here we have two feature. One is our house size and another is number of beds, and the final one is price of houses. So on the basis of house size and number of beds, we are predicting the price of houses. So here we have two feature. First one is a house size and second one is number of beds, due to which this is a multivariate linear regression since we have two features. Okay, so in X I have included my two columns, that is house size and number of beds, and in Y we have prices of houses. Okay, so this is the value that I have included in my X and Y. So here we see capital X and Y is small because capital X is because we have more than one feature, so it should be denoted in capital X so that it shows we have multiple feature, and Y will always be our output, so we will write that in a small later because the output will always be one. In our case the output is the price of houses, so we write small case for Y and capital case for X. Hope that makes sense. Okay, now we will be doing feature normalization. So what is feature normalization is, so this is our standard normal distribution. So the reason for doing feature normalization is because our two feature is in different scale. So our price of houses is in thousands, whereas our number of beds is in 3. So we need to scale this to value in a particular one scale format. For that we use our standard normal distribution z score, which is x minus mu divided by sigma. So let's write the code to generate our feature normalization. Okay, so if feature normalization, okay, will be my x parameter. So so we need to calculate mu and standard deviation. Okay, so my mu is np dot mean of x comma axis equals 0. Okay, standard deviation will be np dot std of x comma axis equals 0. Okay, so our z score will be x minus divided by standard deviation. We will return x norm will be, yes. So right now we have used our standard normal z score calculation. We have implemented within our function, and this what this does is it scales our value in the ratio of 0 to 3, I think 0. So we can see that now the both feature is in one scale. So let's check max. To is our main, so we can see now our both feature are in similar scale. So the use of applying feature normalization is we can have both feature in similar scales. So previously the feature one were in thousand, another were in one digit number. So now we have applied feature normalization so that our feature is in one particular scale, like 0 0.1 minus 0.22. So that's why we did feature normalization. Hope this makes sense. Okay, so our now our hypothesis equation is x transpose of x naught. So so this is our hypothesis. Okay, so this is equals to theta transpose of x. Because why we did transpose, because our theta is in this format, theta naught, theta 1, and so on, and our x is in this x1, x naught, x1, x2. So in order to do matrix multiplication, we know that we need to transpose one value. Okay, so we need to transpose, we need to have our matrix in format theta 0, theta 1, and another in theta 0, x0, x1, okay, x0, x1, x2. So we need to do a transpose of this so that we can do a matrix multiplication. That's why we did theta transpose of x. Okay, so now let's implement this in our code. So one thing to note is our hypothesis is, now we know our hypothesis as theta of x is theta naught plus theta 1 x1 plus theta 2 x2 up to theta n xn. So we are assuming our x naught is equals 1. So our theta naught x naught plus theta 1 x1 plus 1 theta n xn. So we need to create our x naught. So our x naught should be one vector of all 1 1 1 the until the length of data. Okay, we need to populate one vector matrix, then we need to, and our another two feature is x1 and x2. Okay, so as theta of x is theta naught x naught plus theta 1 x1 plus theta 2 x2 right now, because we have two feature. One is this is our house size, this is our bedrooms, and this is all matrix of 1 1 1. Okay, so this is what we need to generate. Okay, so let's calculate x naught first and then append it with our x. So we need to calculate all x11, and our x vector is our house bed size 1203 1454. So we need to generate a final x which does an append of this and this. So it should be 11200 14503 4. This should be in one vector, and another vector theta should be in theta naught, theta 1, theta 2. Okay, So let's implement that. So our x naught will be np dot ones of length of x comma 1. Okay, and our x will be equals to np dot, now we need to append our x naught with x comma axis equals 1. Okay, so we can see our three features. Now we did axis equals 1 because if we do axis equals 1, it will append this as row wise. This will be appended as row wise, sorry, as column wise. So axis equals 1 will append as column wise. If axis equals 0, it will do as row wise. That's why we did axis equals 1. Okay, now let's assume our theta is initially our theta is zeros, comma the shape of 1. Okay, what does this does is it generates a theta. Okay, so now let's write our hypothesis x and theta. Okay, so our hypothesis will be that theta will be np product of x comma theta dot t transpose. Okay, so written theta, so our h theta will be of x comma h t theta. Okay, so let's check with another value. Let's take theta as our np not np 1 2 3. Okay, and as will supply this. Okay, so we are getting our hypothesis, so this looks correct. Okay, so now let's work on generating cost function. So cost function is our error on the module, how much error did we get. So let's write this equation. So in the univariate linear regression, we only had two features. One feature theta naught comma theta 1, this was equals to 1 by 2 m sigma equals 1 to m as theta of x of I minus y of I whole square. Now this has been replaced with our j of theta. So j of theta will be this. Theta denotes can be from theta 1 theta naught to theta n. Okay, so this we have already written this function. Okay, to generate this function we have already written. Now we need to subtract with our output, and then we need to do square, and then we need to take sum, and then we need to divide it by 2n. Okay, so this m is our length, right? And then do sum and then divide by 2n. Okay, so the cost function will be, this will be x, y, and theta. Okay, so my m is length of x. Okay, and h of, we have already calculated our h of theta. So this is my h of theta. Okay, so now we need to do subtraction. So let's say j of theta equals h of theta minus y. And do square. So let's check the shape of this edge is in our horizontal shape. So this is in vertical shape, so we need to do transpose so that both shape is match. Now we need to do sum. Okay, so it will be g of theta that sum. It will do 2y's divided by m. Okay, so and then we return g of theta. So g of theta equals, okay, so this is our error that we receive. So this is working. So now let's write our equation for gradient descent. So our gradient descent equation is such that theta of j minus alpha delta phi delta theta of j. Now it's j of theta. Previously it was theta naught comma theta 1. So now it's been changed to j of theta. This is being excluded. Okay, so this is our formula. So we need to know two formulas for derivative. Suppose if theta of n with respect to d of theta, this will be n theta to the power n minus 1, and we should know d of theta by d of theta is equals to 1. So this is my two convention that we should know about derivative. Okay, so now my theta of j is theta of j minus alpha d by d of theta j, and we know j of theta is 1 over 2m h of theta I minus y of I whole square. Okay, now if we take the derivative, then so we will apply this formula first. So it will be n 1 by 2m 1 by 2 nx to the power n minus 1. Okay, so it will be again will be divided by h of theta minus y with respect to h of theta minus y by h of theta minus y. So we know h of theta is theta transpose of x. So if we take derivative of this, the remaining will be x. So my final equation will be sense. So my final equation will be theta of j equals theta of j minus alpha. It will be h of theta minus y whole of x of j divided by m. Okay, so this is my gradient descent equation. So this is the equation where we get minimal value of theta. Theta is optimal. Optimal value of theta is optimal, and theta is optimal and error is minimum. So we get optimal value of theta and our error is minimum if we implement this equation. This is our gradient descent equation. So let's write our code to implement this equation. Okay, the gradient descent. Okay, so I'll include my x, y, alpha, number of iteration. Number of iteration is to check whether my error is decreasing or not. Okay, so m will be again my length of y. Let's initiate theta to zeros. Okay, this will be my x dot shape. Okay, so let's create an empty list and of number of items. So we will store our error in, we'll append our error here in error list, empty list. So j of theta. Okay, and we even know our hypothesis. Okay, so here we know our hypothesis. What we need to do is we need to we need to subtract with our final output y, and we need to multiply it with x. Okay, so this now what will happen is, and what we will be doing is, we will treat this as our delta. So finally our theta j will be theta j minus alpha by m times delta. Okay, so let's say delta will be dot product of h of theta minus y. Okay, so and this will be again times x. Okay, so let's check whether it's in correct shape or not. So it's in horizontal, it's in row, and this is in column. So we need to transpose this so that these both are in same shape, and then we need to multiply it. We need to do a dot product with respect to x. So if we do minus this minus this, okay, so this is already in row column row, and our x is already in column format, so we don't need to do transpose here. Okay, so and then finally if we do a multiplication of this, have if it will have values up to 1000, so we need to take a sum. So we need to take sum of our delta, but the sum should be row wise, comma axis equals 0. Okay, so this then needs to be divided by m, and finally this needs to be multiplied by alpha. Okay, and then our theta will be equals to theta minus delta's sum. Okay, and then we will return theta comma theta. Okay, let's check. Give one more bracket over here. Okay, so this is fine. So let's call this function. So my alpha is 0.1 and I have iterated. So I have, this is my minimal optimal value of theta, where the error is minimum and the value of theta is optimal. So this is how this is my gradient descent equation for calculating theta. So my theta naught is this, theta 1 is this, theta 2 is this. Okay, so now I will calculate R2 score. R2 score is to calculate the accuracy of my module. So how much accurate my module is. So this is the formula to calculate R2 score. So let's implement this. R2 score. So one thing to note is now we can make our prediction. We know the value of theta. So our predict will be hypothesis of one. So this is my predicted output. Okay. So now let's calculate the R score, y comma y, right? So y will be my y mean. We need to calculate mean. So this is my y minus predicted whole square. Then we will need to take the sum, and similarly likewise we need to calculate y minus mean whole square, and we need to take sum. So firstly I am calculating mean. So this is my mean of y. Okay. So the first one is, so let's take this as numerator, mm, y minus predicted. This is my predicted square. Then we will take sum. Okay. Also, one thing to note is we have appended our error, so we can plot and see how much error do we have in our module and how much iteration we can use. So if we plot this error, so we can see that it is sharply decreasing, and from near about 50 iteration we can say our value of theta is constant, so we don't need to iterate through 1000 loop, and we can iterate till 100, or yeah, till 100 we can iterate, because after 100 we are having our theta is error is consistent. Okay, so we can iterate through 100 loops. That's why we stored our value in array. So yeah, okay, now for our score, so denominator, mm, this is again my file mean. Okay, so let's check the shape first, because this is in horizontal axis and this is in vertical axis, right? So we need to do transpose of this. Okay, transpose of this. So our output will be 1 minus numerator divided by denominator, return output. Okay, so this is how we calculate our score. So let's calculate our score. How much accuracy do we have in our module? Y comma y. So this is mean. Sorry, typo. Okay, so we have 0.73% accuracy in our while implementing this function. We got our score of 73%, 73.2945. Now let's verify our result with a scikit-learn linear module. Okay, so let's import our linear module from scikit-learn, import linear module. Okay, so let's create our linear object for linear module, object dot linear regression. Okay, this is my object. Okay, now let's fit my module, x comma y. Okay, let's predict equals like not predict. Okay, x. Now let's calculate our accuracy, like dot score x comma y. So here we can see the match of our score. So our linear regression model generates the same accuracy that we receive while implementing it through Scratch. So this is how we implement a linear regression multivariate equation. So we have covered almost all the topic, and I will upload this code in GitHub so you can get access to the code. And hope you enjoy this video, and please do like my and subscribe my channel if you want to see similar videos. Thank you so much.